Alright guys, so for today's mini lesson we're going to be talking about absolute value equations and inequalities. Right? So at this point what you've learned in terms of absolute value is no matter what number you put into an absolute value bar, it's always going to be positive. Okay, so when we're solving absolute value equations, we have to work backward from that. So no matter whether you put a positive 4 or a negative 4 in here, the answer would be 4. So when we work backward, we say our answer either has to be x equals 4, okay, but it also, we have to take into consideration the negative. So whenever you're solving an absolute value equation, you're going to have two solutions. One representing the positive possibility of the absolute value of 4, but also the negative possibility. Okay? All right. So now, if we take a look at problem B, we have 7 equals the absolute value of x plus 2. So whatever the absolute value of x, we add 2 to that, we get 7. So before we start considering the absolute value, we first want to get the absolute value part by itself. So I'm going to subtract 2 on both sides. So now I get the absolute value of x is equal to 5. Same thing as above. We don't know whether x is positive, okay, or x is negative. So we say that it's both. X equals 5 and x equals negative 5. Okay. All right, for C, we have absolute value of x plus 8 equals 4. All right, so just like we did before we can evaluate the absolute value, we have to have the absolute value by itself. So I subtract 8 on both sides. This leaves us with the absolute value on the left, and we get 4 minus 8 on the right, which gives us a negative 4. Now, one of the things that we know about absolute value is that it's never going to be negative. So, because of that, when we say the absolute value of some number equals negative 4, it's not possible, so we say no solution. Okay. All right, for D, we have 2 times the absolute value of x plus 5 equals 4. So once again, just like we had to add or subtract to get the absolute value by itself, here this says 2 times the absolute value of x plus 5. Now, contrary to popular belief, we cannot distribute the 2. So to get rid of it, we have to divide. Right? These are not parentheses, they're absolute values. So we don't distribute. We say absolute value of x plus 5 equals 2. Okay, now here, the absolute value is by itself. Yes, we have a plus 5 in the middle, but we go ahead and evaluate this as just a single expression. And so from here, we go ahead and we say x plus 5, that's what's inside the absolute value, equals 2, and x plus 5 equals negative 2. Right? Once we have everything outside the absolute value by itself, then we can set it equal to the positive and negative value that absolute value is equal to. Okay? So once we have set those up, then we can finish solving. Subtract 5 on both sides. X is equal to a negative 3. Subtract 5 over here. X is equal to a negative 7. All right, so this time we get x equals a negative 3 and x equals a negative 7. All right, moving on. For E, I've got absolute value of 3x minus 6 equals 12. So this time, notice we don't have anything outside the absolute value. So we can go ahead and say 3x minus 6 equals 12, and 3x minus 6 equals a negative 12. Right? Both of those are possibilities for whatever expression is inside of this. Okay? So we're going to go ahead and solve once we've set those up. 3x equals 18. We divide by the 3. X is equal to 6. Okay, but we also have the other possibility over here. We say 3x is equal to a negative 6. We divide by 3, and x is equal to a negative 2. All right, so we have 2 answers. All right. Okay, so let's look at one more problem of equations, and then we're going to look at some absolute value inequalities. So first thing, we have to get everything outside of the absolute value gone. All right, so where it's 2 times the absolute value of x minus 17, we're going to divide by 2 on both sides. We're left with the absolute value of x minus 17 equals 9. So we say x minus 17 equals 9. X minus 17 equals a negative 9. Add 17 to both sides. X equals 26 here. We add 17 over here, and we get x equals 8. All right, so we still have two solutions. There may be different numbers, but that's the nature of the absolute value. Okay. All right, so absolute value, we have to set it. We get the absolute value by itself. Then we evaluate those absolute value expressions. Okay, take a look at all these. We evaluate those absolute value expressions, so that way we have a positive and negative value. But remember, you have to get the absolute value by itself. And in some cases, once you do that, you then have to solve two separate equations in the end, depending on where your different numbers are. Okay? So go ahead and flip over to the back. We're going to take a look at absolute value inequalities next. Okay? So here we're going to solve these just like we would an absolute value equation. Okay? But if we think about this, we're saying some number, the absolute value of that has to be less than 3. So if I think about like a number line, all right? So if we think of this first off kind of as an equation. If I say the absolute value of x equals 3, we solve. We know x equals 3, x equals negative 3. Right? But on a number line, if I take 3 and negative 3, whatever number this is has to be less than 3. Right? So essentially, our answer is going to have to be anywhere in between these two numbers. Okay? So we can set it up as a compound inequality, what we looked at the very beginning of the year, and we can say that x has to be less than 3, okay, but also greater than negative 3. We can write it like that. Okay, or we can write it as x is less than 3 and x is greater than negative 3. Okay? Alright, so let's take a look at the next one. Let me zoom in on these a little bit more. Alright, so for B, this time it says the absolute value of x is greater than 3. So we're starting to think of numbers, no matter only the positive values of those that are greater than 3. Right? So if I think of a number line, sometimes it helps me to think of a number line first. Right? I know 3 is right here. We also know those numbers, so if I think of the negative 3 as well. Right? First off, what are the positive numbers that are greater than 3? Okay, well, they're anything to the right. Right here. Okay, well, what are the negative values once we take the absolute value? Well, negative 4, once I take the absolute value of that as positive 4, it's greater. All right, so it's all the numbers to the left of negative 3. Okay, so how do I write this answer? We say x is greater than 3 or x is less than negative 3. All right, so this part is the x is greater than 3. This is x is less than negative 3. So we write it as an OR statement. These are our compound inequalities we looked at the very beginning of the year. Okay. All right. Absolute value of x is greater than 15. All right. So we're thinking of numbers after we take the absolute value of them are greater than 15. So sometimes it's helpful to write it on a number line. Sometimes you don't necessarily need to. Right. But for me, it's helpful to conceptualize it. All right. So I've got 15. I've got negative 15. What numbers are greater? Well, I know 16, 17, 18, so on and forth are greater. Okay, so if you look at negative 15, right? Negative 14 is right here. Negative 16 is right here. When you take the absolute value of either one of those numbers, which one is greater than 15? Well, negative 16 is. So we shade over here. Okay, so my answer, so we say x is less than negative 15 or x is greater than 15. Okay. All right, let's look at a couple more of these. All right, we've got absolute value of x is less than or equal to 7. Main difference here, okay, is it says less than or equal to. Okay, so Big difference here is I'm going to put 7 and negative 7 on the number line. But at these points, instead, we're going to put closed circles to represent the less than or equal to. Okay, now less than. So if I think of some other numbers on my number line. Oops, that's a positive. All right. Numbers to the left and to the right. All right. Well, once you take the absolute value of 6 and 8, which one is less than or equal to 7? Well, 6 is. Right. When you think of the negative 7, when you take the absolute value of negative 8 and negative 6, which ones are less than 7? Well, the negative 6 is. So your answer is going to be everything in between here. So we can write our answer one of two ways. We can say x is less than or equal to 7, greater than or equal to negative 7, or you can also write it as x is greater than or equal to negative 7, and x is less than or equal to a positive 7. All right. Okay. Next one for E. Absolute value of 4x minus 175 is less than or equal to 20. So before we do anything, I'm going to treat this one like an absolute value equation. Then once we know what the x values are, once we know the parameters of our graph, then we can take a look at the inequality. Right? So just like we did with the equations, there's nothing outside of the absolute value. So I'm not going to do anything first, but what we're going to do is we're going to take the 4x minus 175, set it equal to 20, and set it equal to a negative 20. Okay. I'm going to solve both of these equations. So that 4x is equal to 195, and over here, and then we'll divide by 4, and x is equal to 195 divided by 4 is 48.75. Okay. Over here, we're going to add 175. 4x is equal to 155. We divide by 4. And we get 38.75. All right, so these two numbers are going to be the parameters on our number line. All right, so I'm going to think of it like this. We've got 38.75. I've got a positive 48.75. It's less than or equal to. So whatever values have to be less than or equal to. Anytime it's a less than or equal to, right, just like we looked at before, right, our shading is going to be in between, and that's going to represent an AND graph. So I can say x is greater than or equal to 38.75, and x is less than or equal to 48.75. Or we can also write our answer as x is less than 48.75, greater than or equal to 38.75. Okay. So either one of these you can write your answer as. Okay. All right, guys, we got one more. Okay, and then you're going to get on Math Excel and Pearson Realize, and then try some of these on your own. So with this, I'm going to treat it just like an equation at first to get my parameters that we talked about before. Right? So we're going to say 3x minus 6 is greater than or equal, is equal to 9. 3x minus 6 is equal to negative 9. Add 6 to both sides. 3x equals 15. Divide by 3. X equals 5. Right here we're going to add 6. 3x is equal to a negative 3. Divide by 3. X equals negative 1. Alright, so make my number line. I've got negative 1. I've got 5. I've got zeros right here. We're talking about the absolute value of an expression that is greater than or equal to 9. Right? So it helps to think about where your numbers will be greater. Right? So greater, my bigger numbers are to the right. So we're going to put a closed circle because of the greater than or equal to. Okay. Now here, this one's a tricky one because you have to think about not the greater numbers, but the absolute value of those numbers. So when we go to the left, right, the absolute value of the numbers are getting bigger, right? So we are going to go left. Okay. So the absolute value of 3x minus 6 is greater than 9. We can write our answer as x is less than or equal to negative 1, or x is greater than or equal to 5. Alright guys, and that's it. So I've given you instructions on how to access Pearson Realize, and you should be good to go.